Hi there. Today we're going to learn about surface area of cones. So let's go over what a cone is. A cone is similar to a pyramid in the sense that it has one base and it has a vertex at the top. Now instead of having edges, because the base of a pyramid is a polygon, meaning it has sides. So a pyramid has sides. It's a single base, and because it has sides, it'll have edges. And we call this, remember this, that line down the middle that was perpendicular to the base was called the slant height. Well, when we have a cone, put that over there. When we have a cone, we still have a slant height, and it's still perpendicular to the base, and so that will be the slant height of the cone. And then it has a circular base, so it'll have a radius or a diameter, and then you'll have that. So if we're talking about the surface area, that's the lateral area, and this is the base. So if we have that in our little diagram here, and we slice it, and we take the bottom off, we see what we get. We get almost like a fan. Oh, that's so nice. It's less than a half circle. So this is the slant height, or the height of the cone, and then this distance, again, much like in all of our distances we've had on our slant, this is the circumference, because that makes up the distance around the circle. So that's going to be, what do we call that? That's 2 pi r if it went all the way around, all right? But we're going to have a formula. This is actually just half of, well, it's not really, it's called pi r, because we're going to take that as our lateral area. And then we have our base, which is a circle, and the area of a circle is going to be pi r squared. So let's take a look-see here. And where's my surface area notes? I'm going to make this guy, I'm going to make me smaller. And now let's look at our diagram. So we have this cone, and the cone is upside down, and it has a slant height of 15.7 centimeters. So this slant height is going to be 15.7, and that distance is that, because that goes down to the base, goes from the top here down to the base, and then we have the radius. The radius is going to be from here out. Okay, so understand this looks like the radius, but this, in your lateral area, this is going to be your slant height. We see that. And this is going to be the circumference around. This is going to be your circumference around the circle. That's going to be that distance. So there's a formula that we can use, and it's going to be the height times pi r. So notice it's not the true circumference, because we need to multiply it by, we're sort of doing a base times height, but this isn't a rectangle or a square or a polygon, so we're going to use pi r h. And then something that we should be very familiar with is the formula for the area of a circle, which is pi r squared. So that should be easy. Remember, we only have one base, so we're only going to see one circle. This is going to represent the lateral area. It's going to be this portion. It's going to be the lateral area. So we calculate that by multiplying pi r h. And then we calculate the area of the circle by multiplying pi r squared. So let's take a look at that, and let's see if we can solve it. So if we plug in this information, let's Actually, let's send you back down. Let's get my pointer for a second. And let's see if we can fill in those values. So the first value is pi. Well, we're going to plug in 3.14. The radius is 7 centimeters. And the height, meaning the slant height, is 15.7 centimeters. And then we're going to take that value and we're going to add it to pi r squared. So again, we're going to use 3.14 for pi, and then our radius is 7 centimeters quantity squared. So let's get our calculator, and we have 3.14, let's turn it on, 3.14 times 7 centimeters gives me 21.98 centimeters, and we have to multiply that by the height, and we have 3.14, and 7 centimeters squared is 7 centimeters times 7 centimeters, which is 49 centimeters squared. Now let's take our 21.98 centimeters and multiply it by 15.7 centimeters, which gives us 345.086 centimeters squared. And we're going to add that to 3.14 times 49 centimeters squared, which gives us 153.86 centimeters squared. And now let's add the lateral area. This is the lateral area plus our single base area. If we add those together, 0.086 gives me 498.946 centimeters squared. That would be the surface area of that cone with a radius of centimeters and a slant height of 15.7 centimeters. 498. So let's try this one. So you do take a look at that one and see if you can figure out, using the formula, surface area equals pi RH plus pi r squared. This being the lateral area, this being the base area. Base shape is a circle, so we would use pi r squared. So take a moment to do that work. Put it in your notebook. Again, we're trying to keep track of our work. Pause it, and then when you're ready, unpause it, and we'll see the solution. So here we have pi RH plus pi r squared. We're going to plug 3.14 in for pi. Our radius is going to be 11 miles, and our height is going to be 24.6 miles. Again, our pi, we're going to plug in 3.14, and our radius, we're going to plug in 11 miles. So 3.14 times 11 miles gives me 34.54 miles. And then we're going to multiply it by the height. And then here we have 3.14 times 11 miles squared, which gives us 121 miles squared. And then we'll multiply these two values together, and multiply these two values together, and you get 849.684 miles squared plus 379.94 miles squared. Add those two. This is the lateral area. This is the base area. We'll add those together and you get 1,229.624 miles squared would be the surface area. That'd be a lot of surface area. All right, let's take a look at this one. I'm going to give you one more challenge problem, and notice that this time we're given the diameter. We're still going to use the formula, surface area equals pi RH plus pi r squared. But understand that when you plug in for the radius, you need to calculate what the radius is. You're not given the radius, you're given the diameter. So take a moment, pause the video when you're ready, unpause it, and see if we have the same answer. So surface area equals pi RH plus pi r squared. We're going to plug 3.14 in for my pi. In both places that I see pi, I'm going to plug 3.14. For my radius, notice my radius is 16, my diameter is 16 kilometers. So my radius would be half of that. That would make 8 kilometers. So notice that I plugged in 8 kilometers for my radius, and then my slant height is going to be that distance, and I'll plug in 17.9. So first thing I did was I multiplied 3.14 times 8 kilometers and got 25.12 kilometers. I then squared 8 kilometers and I got 64 kilometers squared. And then I multiplied 25. I multiplied 25.12 kilometers times the height, and that gave me 449.648 kilometers squared. And then I multiplied pi times 64 kilometers squared, which gave me 200.96 kilometers squared. Remember, this is my lateral area, and this is my base area. And if we add those together, we should get 650.608 kilometers squared. So hopefully that makes sense. What I would advise everybody at this point is to be making note cards and to be somehow writing down these formulas and having them organized in your notebook. So make sure that you're memorizing the different area formulas and the different surface area equations. Okay? I hope to see you on Tuesday morning. If you have a question, Tuesday we're also going to have not only office hours in the morning, we're going to have our pre-assessment, and then at 1 o'clock I'm going to have a Q&A for people who have already taken the pre-assessment. So if you want to partake in that Q&A, you have to do your pre-assessment prior to 1 o'clock and submit that exit sheet or that score sheet. And then Wednesday we will have our assessment. Thursday we will have our reassessment. And Friday, I know it's Good Friday and we don't have school, but there's a fun activity that you can compete over the week of our vacation. And it's a fun little challenge problem. So I will hopefully talk to you on Tuesday. Thanks.